charge. I'm just starting the recording.
All right. Well, actually, Derek
just knows them, and the speaker things are right there on the corner.
Yes, the speaker thing. Those are
Mariah?
these are the coveted awards, and we may need to find another one because I think there are.
I got two. I was told make two. What's
There are
up?
only 2 speakers.
Oh, well, we have to tackle each other. For the. Anyways.
It's not just the sales guy. He doesn't really
Don't
deserve a special thing.
If he's not speaking, he's.
Yeah.
Okay. Technicality. Anyways, welcome. It's good to have you here, and thank you very much for Timescale for being here. The food, they sponsored that. We're just grateful to have them here. Derek's going to give a little info, kind of a little history, which I think will be very useful to understand the context of where things are today. First of all, who's heard of Vitess or Vitess or which way you're going to say it? Yeah. Who's actually using it?
In production, Derek.
Okay. Well, hopefully after.
Production, I pretend.
Okay. Pretend there. Hopefully after today, maybe there'll be some more dipping in the water there. But go ahead, Derek.
I've been pushing Vitess hard for the last few years. I don't know if any of you have come. I've spoken about it 2, maybe 3 times, I think. Today, there are better people to talk about it. They're all awesome. I've been out to the Planet Scale headquarters a couple of times, had delicious Chinese food that was then shut down because they had violations, but it was worth it. Anyhow, Vitess is great. We've been using it. We started looking at it almost 3 years ago. We've been using it in production for a year, and they really know what they're doing. It's the right trade-off, in my opinion, of it's not like Cockroach, it's not quite so magical, like it's a little bit higher learning curve, but because you get to choose, you spend your time choosing and architecting where your data lives, you can get much better latency, pushes most of it down to MySQL. It's not some brand new engine, and it's battle tested. So if you do it right, most of your workload stays on a single MySQL instance. You get all the power and reliability that has. Anyway, I'll let them go, but Vitess is the best. And it has message queues. Never use Kafka, it's garbage.
Never use Kafka, it's garbage.
Or anything else, because you can do transactional, you can act to queues, you can add to destination queues, and do your data work all in a single transaction. You don't have to deal with orphaned rows or, oh, it added to the next queue but didn't act, or vice versa. Anyway, it's great. It saves a lot of work.
Thanks, Derek.
That's good. Okay. Do I have to do anything for audio, or can I just speak loud?
So the room is mic'd.
Excellent.
So we got all commentary.
Okay.
So I can hear people whispering.
Great.
I can hear, but that way we can do any Q&A is recorded.
Great. If we have hecklers, we can edit them out.
Fair warning, though, it really does pick up whispers. So if you don't want to be on the recording, that's what you say.
So hello, everyone. My name is Morgan. The title of the talk might seem a little bit interesting. If you've only used the product for 90 days, why are you talking about it? I presented this about a month ago or a couple of weeks ago at the Picona conference in Europe. My background is that I previously worked on MySQL. I was a product manager for the MySQL server. This is me kind of evaluating Vitess and saying what I think about it, what I thought was interesting, where I see a good fit, and so on. So Vitess has some interesting history. But here's my agenda to discover or talk about what we're going to talk about. First, I'll give a brief overview of Vitess. It's a little bit hard to define exactly what Vitess is. I think the simplest definition is probably to say it's a bit of sharding middleware for your database, but that's too simple. It does more features in addition to that. We'll talk about some terminology. This helped me learn Vitess by understanding what a tablet is, what a cell is. The terms that Vitess use will help you understand it better. And then we'll talk about my questions really from the database perspective. What does Vitess offer in terms of its guarantees? Is it kind of like a NoSQL system, or is it more like a traditional relational system? So I'll give you kind of my version of that. And then some sort of quirks that I discovered along the way that I thought were particularly interesting. So Vitess, started at YouTube about 2010. The YouTube team, they were using MySQL as their database, and they were needing to scale. This was definitely the phase of them for rapid growth. And a single monolithic MySQL database was never going to cut it. So they looked at how to solve this problem, and thankfully they solved it in a generic way. I think the way that a lot of people solve this is they modify their application and they put some sort of sharding technology in the application that knows which database to connect to. They created Vitess. Vitess allowed them to present a single view of the database layer to the applications and manage the MySQL for them. So Vitess, it is a middleware, and it does kind of proxy where it sits in front of your MySQL servers and looks like MySQL to your applications. But it also handles some of the functionality that you need to manage a large system of lots of MySQL servers, where it provides monitoring and it provides backup, provides this orchestration of having all of these thousands of servers, as was the case at YouTube. And it has some additional features that are kind of interesting. Derek, he said he's a big fan of messaging, but it also has the ability to replicate your data to other shards and then prepare it in a different view of the data. In traditional databases, we might call a materialized view. This feature is also possible in Vitess that's not possible in MySQL. So I would say certainly sharding is one of the big things if you've got a large database and you're trying to figure out how to grow. But Vitess also has some free features that you get on top of MySQL, completely absent from sharding, and that you get that monitoring and that backup automatically installed and set up for free. And it has some things to be able to eliminate toxic queries, so it'll deduplicate queries if many come into the Vitess system at once. It'll make sure that it doesn't overload your database system. You're very production focused, very aware that these are the things that can bring your systems down, and these were the problems that YouTube was trying to solve. So that's my closest definition to say that Vitess is a system that allows you to scale MySQL to very large sizes. It also allows you to deploy MySQL in a very cloud-native way, because I think the traditional way that you deploy databases is that you have this massive monolith, and then you provide HA perhaps in hardware, and maybe if it does fail, then it's manual failover. It's very different from the cloud way, where you move from having pets to having cattle. And I think, simply put, Vitess allows you to manage MySQL like it's cattle instead of being like pets. And this is really no surprise, because YouTube, being part of Google, Google had their Borg system. Google developed Kubernetes. They always wanted to manage things in this cloud-like way. Vitess is in use at many companies. It's no longer just YouTube. YouTube was the original creator, but they open sourced it a few years ago. And then as it started to get some traction, YouTube donated it to the CNCF, the same part of the Linux Foundation that hosts Kubernetes and other software products. And then from there, actually, as well, the company that I work for, PlanetScale, Sugu, the original co-creator of Vitess, decided to commercialize and prepare a company to provide support for Vitess users. And so Sugu and his co-founder, Jiten, started that company 12 months ago. Let me describe some of the terminology and the architecture, and then I'll have a summary, I think one slide forward, to describe the essentials that really help you understand Vitess. So here we have our MySQL server. Actually, doesn't work on the screen at all. Okay. So we call these tablets in Vitess. And a tablet is the combination of a MySQL server and this VT tablet process that kind of manages that local copy of MySQL. And in this particular system, you can see that we have 1, 2, 3, 4 shards. And each of those shards has replicas as well to make sure that data is redundantly stored. This is all managed by Vitess. So your application, they don't have to worry about each of these shards. All they have to do is connect to VT-gate. And commonly in cloud architectures, you'll put a load balancer in front of that. You can choose your favorite TCP load balancer. And then VTgate itself is stateless. So you can think of this as a router that you can add and scale this out or in as you need to. All of the persistence is stored in MySQL, the regular MySQL that you're used to operating. And the metadata to know routing information is stored in a topology server, or as we sometimes call it, Topo. So Vitess supports etcd, which is common in Kubernetes environments. It also supports Zookeeper and Console to be able to store that metadata. So
Person has a PR open to actually use the Kubernetes API server.
It's not finished. There's no reason, I mean, there's no reason with custom resources you can't actually get the same.
Right. It's quite extensible. And the other thing that's kind of interesting about it, it's not actually used as part of the active query serving path. So this makes it quite scalable as you need to add capacity, you're either adding more VT gates, which being stateless is very easy to do, or you're choosing to add additional shards to increase your scale. So we like to say that there's no known scalability limits in Vitess. It's quite easy to horizontally scale by adding additional nodes at either of these layers. I'm really interested to see that PR because I think it will simplify deployments if that's possible.
It's like half baked because I don't know enough about. I was learning, doing it while I was doing Vitess, while I was doing the operator.
Okay.
But I mean, I looked at it and went, like,
Yeah, there's not too much you have to implement.
Just interface on top of etcd mostly, right? So,
Right.
yeah, it'd be nice.
And Vitess did actually recently change the default to etcd because it's quite popular environment, so it's working.
It's a lot better than Zookeeper.
Yeah. So terminology essentials. What I described a few of these in the previous slide, but VTgate is the name of the proxy. This is the path that your application connects to. And it speaks the MySQL protocol. It says, hey, I'm MySQL. And you can use any of the existing connectors or drivers, whatever your preferred language that your application uses to connect to MySQL. And then it manages that connectivity, that routing under the hood to be able to retrieve that data from MySQL. The Topos server, or the topology server, that contains the metadata. And the tablet is the combination of a VT tablet process and a MySQL server. There's two new bits of terminology that I didn't mention when I showed the previous architecture. One doesn't really describe too well on that previous slide, which is to say that you have a key space as a concept. You know, if you're used to operating with MySQL, you've got schemas or databases to say that, you know, this is a logical container of tables. The Vitess terminology to disambiguate is that you have a key space. The key space could actually be sharded. So there's actually multiple copies of this, or multiple parts of this, also of these shards, or it could be unsharded. There actually are some benefits to operating Vitess with unsharded key spaces. Is that VTgate process can do a lot of things for your application to make it operate better in production. And the other thing that's not really well described here is that this system that Vitess uses to manage your replicas, it also understands data center locations, what it calls cells. So you can set a policy to make sure that you have a copy of your data in some other cell, some other AZ or some other region if we use AWS terminology. So as I said, I found these really helpful to get to know Vitess. And my immediate questions when I started using Vitess were really these ones. What version of MySQL is it? VTgate pretends that it's MySQL 5.5. I think we'll probably bump this at some point in the future to say that it's MySQL 5.7. Perhaps the reason why it's a little bit lower than most MySQLs is it doesn't want to pretend it's capable of all of the syntax in the world. There's some syntax that's not possible in Vitess, and we'll get into that in just a second. But what versions of MySQL does it support underneath? What versions is it managing? Most users are using MySQL 5.7. That seems to be the most common. But Vitess is fairly agnostic in what version of MySQL you run. So if you want to run MariaDB, you want to run MySQL, you want to run Aurora, all of this is fairly possible. It just needs something that's MySQL protocol with a couple of other dependencies around row-based replication and something called GTIDs if you're not familiar with it in the MySQL space. If it's managing your replication, it strongly recommends that you use something called semi-sync, but it's not strictly a dependency. The dependencies is just really this line here. So that was my first set of questions, and I think they're fairly easy to answer. My second set of questions, obviously, is if Vitess is acting as this proxy, and it can retrieve data from all sorts of various locations, what sort of queries are possible? Can I join against different shards that access multiple pieces of data together, and will that query work? And the answer is it depends. It actually does work for the most part. You can do a join query across multiple tables that are in different locations, but if the key space is sharded, there are some restrictions. So if I tried to do a query, for example, where I was retrieving the data and grouping it, and then after grouping it, I was ordering it by a different column to what I grouped by, logically what has to happen here is this data has to be materialized or temporarily stored in VTGate and then reordered. And VTGate doesn't currently support this. It really wants to find a way to execute the query where it can just stream or pipeline those results from the underlying MySQL service directly to the application. So if you keep that in mind, that's one of the major limitations. We have ideas, I think, of how to fix this in future and support more complex queries, but I would call them the idea stage. There are no current plans, and so you might have to find a way to execute this query slightly differently. Maybe you don't do the ordering, in which case it should be possible to be able to stream all of these results directly from MySQL directly to your application. The other major limitation is, if you're familiar with some applications, they like to set session variables inside of MySQL, where they might say, set this particular buffer to this value. Vitess uses a connection pool to be able to defend the database from rogue applications that set a lot of connections up. And there's no guarantee that this particular variable, when set, that connection will be reused for you on the next command that you execute. So many of these settings that you set, you'll just get an error if you attempt to do that. There's some that are known to be safe, to be ignored, in which case the parser just kind of whitelists them. So I think a lot of drivers, for example, set the SQL mode to something crazy, and then Vitess just goes, I know I can drop that, just to enable compatibility. Yeah, so like you had an additional thought to add? No, okay. There are more. I think Vitess is fairly transparent in saying which queries are not supported, and so as you get my slides, there's a link to describe more. But these are the major two cases of what to be aware of. My other questions, I say, where does it fit in? Is it a NoSQL system? Is it a little bit loosey-goosey with data where you say store this, and it says, yes, most likely I will, but maybe I won't if I have a crash? It's a lot closer to traditional relational databases than it is to newer systems. Because it's still MySQL under the hood, it's still using MySQL to save the data. It's a lot safer in the level of commitment or honoring with these asset semantics, if you're familiar with database acronyms, that it is to like in a NoSQL or eventually consistent system. There are some exceptions to that though. So with Vitess, we don't recommend that customers do an update where the update would be happening on two shards at once. It does support the ability to make sure that that is consistently updated in something we call a two-phase commit, but it's slower and it's really not recommended. And I don't think at PlanetScale we have any customers that are currently using that. We suggest that you design the way that you're sharding such that this is not a problem. You'll be much more successful. It also does have some elements of eventual consistency where when it provides these materialized views with this feature called vReplication, which I'm sorry, this sounds a bit vague, but I'm going to try and not go into the details. These are eventually consistent. So it uses MySQL's replication stream to get copies of the data as it's being modified, and then it does a best effort to keep it up to date as fast as possible. So there are some caches of the data that might be delayed a millisecond, half a millisecond, or if you have some blips, a few milliseconds. It's not guaranteed to keep it completely up to date. Some other things that I thought were interesting as I started learning Vitess. The VT gate does actually pass the queries. And it does make a best attempt to not modify the queries as it's passing them before it sends it to the backend MySQL server. I like this behavior because it's very common in large MySQL deployments to add comments into your SQL queries so that you know which part of the application issued this query, so you can have full tracing going from front to back or back to front, essentially, to be able to discover which developer you have to talk to fix something. So that was a nice surprise quirk to find in Vitess. The other thing that I think is interesting coming from a MySQL background about Vitess is that MySQL is kind of renowned for being really loose with how it stores data. So if you have a varchar 10 and you insert 20 characters into that varchar 10, now you don't get an error, but once upon a time, so now you get an error, once upon a time you just get a warning, and many applications actually ignore that. I think this is a very different history from Vitess. Vitess was never so loose with storing data. The original design of Vitess actually presented a gRPC protocol to the applications rather than a MySQL protocol. And it had type safety. So if you didn't get just the types correct, you would get an error. And I actually think this is the better place to start from, because it means that, you know, if Vitess doesn't support your particular query, you're more likely to get an error, and you'll know about this than not know about real compatibility issues until you deploy it in production. So it does work well with that sort of a couple of slides back where I said, here are the constraints. You know very quickly if you start using Vitess or trialing Vitess if it'll support the queries, because it will give you errors. It is quite pedantic in that respect. Some other things that were interesting in learning Vitess. Vitess recommends that you keep shard sizes to 250 gig. Coming from sort of the MySQL background, I thought this is incredibly small. You know, I have many users that have terabyte-sized databases. The main motivation for doing this is Vitess wants to make sure that restores are as quick as possible. So 250 gig tends to be about the right size, that if you have one of your servers fail, one of your tablets fail, you can reprovision it somewhere else within about 10 or 15 minutes, as long as you've got about a 10 gigabit network. So from that perspective, I think it's very cloud-like to manage things a lot more like cattle than pets by picking that size. Okay, let's talk about sharding briefly. I would categorize Vitess as sharding as translucent rather than transparent. You are still designing how you want to split your data up. And so Vitess gives you a number of choices in sort of which function to hash your data on, or which column to hash to decide where this data is going to reside. It is quite flexible. It is even extensible, and you can add your own mechanisms for how to split the data up. It does recommend that you model the data so that, as I said, updates are on a particular single shard rather than across multiple, as this is not very good for performance. I think this is a bit different from some other newer systems where they will automatically distribute your data. Nothing's for free. They have a potential trade-off, or they have a very real trade-off, I should say, in that anytime you do an update, it has to do a lot more network traffic to ensure that it was consistently updated with a two-phase commit. Vitess integrates very nicely with some prepackaged software. If you're from the MySQL space, you'll be familiar with Percona Extra Backup, MySQL and MariaDB's replication system, and Orchestrator. And as I said, you get to choose which Topos that you want to use. So last couple of slides, what do I think Vitess is a good fit for? I would say these are clues. They're not the entire list. But if someone says to me that they have a multi-tenant application, maybe they're a SaaS company, and it's a very common pattern to have an individual schema per customer that they serve. Vitess is a much better solution than that. Quite frequently, these users that do that, they run into a case where MySQL is not having problems with the amount of data they have, it's having problems with the amount of metadata they have, because they have millions of tables on an individual system. Having the Vitess VT-Gate handle that routing is a much better system. So that kind of relates to the first 2 points where it's a multi-tenant application. It is a better way to do that. It's also a better way to be able to divide the load between each of your servers. If we talk about one of the users of Vitess that's quite successful, Slack, they started with a scheme that was kind of similar to this, where they had their individual tenants on a MySQL server, but they found that the load was not evenly distributed between them. So Vitess allows you to pick a better key to shard on, essentially, and quite frequently get better uniformity than picking just the tenant ID to shard on. If you need an upgrade path from MySQL to sharded MySQL, quite frequently the way to scale MySQL is vertically, which is not really a cloud pattern. It puts you in this position where you're creating pets and not cattle. And if you want to manage your databases in Kubernetes, it makes it much easier to be able to do that, as you're picking this smaller shard size and it's doing all of that orchestration and management for you. My last slide is to say, no such thing as a free lunch. What should you be aware of? Vitess still uses MySQL underneath. There are some things that MySQL is not as good at. I think very intelligently they're focused on what they're good at, and MySQL is very popular in what we call transaction processing in the database space, which tends to be simpler queries, at high frequency, not the analytics style queries that tend to be in lower frequency. And so if you're in the case where you've got all of these custom queries that access a lot of data at once, it may not perform so well as a result of being MySQL underneath. There are some mitigating circumstances with vReplication, and also the VT gate. If it does retrieve data from many locations, it does do it in parallel. MySQL itself does not support much in the way of parallel query execution. And the other thing that I would say that's kind of inherent to Vitess being developed at Google and being an internal project first is that ease of use was not a day one priority. So there are some things that are a little bit hard about Vitess to get started, as they've chosen a more complex or complete path on how to implement something rather than an easy path. And so at least in Planet Scale, as we commercialize and develop Vitess, this is a priority for us. If you do notice that something is hard to use, we are trying to make it better. I think that's it. So if you have questions about Vitess, the best place to look is on the Slack channel.
Or ask Derek.
Yeah, or ask Derek. Or you can ask me. Are there any questions about my talk as well?
Any questions? People feel questions?
So you mentioned sharding on a different key than your tenant ID, for instance.
That's right.
Like, just as examples, do you have any thoughts on scenarios where that really works out well, or I don't know?
Right.
I never really thought about it. So yeah.
That's a great question. I'm going to throw that to Jen as well, but I'm going to answer first. So, I use the example like Slack, and what can happen is that you end up with your tenants lopsided, or worse, as your business grows, if you're a SaaS, you start attracting bigger tenants, and some of them might be too large for an individual server. So then you need to restrict the features you offer, and it's just not a good place to have your business. So in the case of Slack, there's many sub things you could kind of shard on. You could shard on the channel, or you could shard on the users, like the tenant of the tenant as a different model. And often this will get you better distribution.
That's exactly right. So as long as a single vendor or a single tenant doesn't outgrow a single database cluster, you're fine sharding with a vendor ID as a sharding key, right? Because Vitess does give you very fine-grained control about what data will sit in one shard, right? But the moment your one vendor outgrows a single cluster, as Marvin said, you probably need to go one level below. So probably say order IDs might make sense. So that does have a bad effect that orders associated with a particular vendor don't live in the same cluster. So you might need to think that through, depending on your app. But those are the trade-offs.
So if you're sharding on the tenant ID as well, you're also limited to the parallelism in one tenant goes to one server, right?
That's right.
So, okay, so there's also those trade-offs. That's interesting. Okay.
Yeah. That's an interesting question. That's actually very hard to answer as well. Like, you know, at some level, you want to have the data locality so that it fits in one shard. But if that's not going to work, then another model that kind of is interesting is to have it distributed so you can access all of them in parallel. And there are advantages to both.
So we have 4 different sharding keys. We have a tenant sharding key, we have a user sharding key that are different key spaces. We get a bunch of information about URLs, and we shard on domain ID, though that has led to some lopsided shards. So we're rethinking that. But the thought was, then if we want to do any kind of analytics on a single domain, then we can run that on a single shard. Then we also do like searches. So we track Google searches basically. And so we have a keyword ID that we shard on. And so we kind of have, we grab a search, we get the top 100 URLs, and we kind of do a handoff to the next key space to say, go get a bunch of URL metadata and store it, sharded by domain. And then we kind of, at the end of the day, we map it together and we actually leave Vitess and put it into BigQuery for actual dashboarding. But the stitching only happens together at the very end.
So what's the migration path? I mean, you have an existing large database or a HA cluster.
Right.
What's the best way to migrate into the Vitess system?
So there are a couple of ways that you can do it. I will mention one feature that I didn't describe. The VT tablet process, it can actually support an external MySQL. So you can actually start with Vitess on top of your existing MySQL system. And I like to do this because it allows you to test compatibility. The Vitess doesn't have any state here, so you could send part of your application through Vitess and part of your application through the traditional route. And that's kind of like a validation step. From there, you can choose to move it into Vitess. And we have some tutorials on how to sort of reshard your data because you're probably moving from a very large monolithic system, and then you want to split it up into MySQL, into smaller 250 gig shards. And so there's a process on how to do that that's documented on the website. Does anyone add anything?
No, yeah. What Morgan said is the way to migrate basically. You first just start Vitess as a middleware in front of your existing cluster, send part of your traffic, make sure that reads are working, make sure that writes are working, figure out which queries are not working, tweak them and so on. Slowly turn it up to 100% and you are there. But the point that I wanted to make was that Vitess, one really cool thing about Vitess is the bulletproof nature of all the operational pieces. So the resharding can happen, your first resharding might take weeks, depending on how big your database is. But that resharding might be running in the background while the data is first being stale copied, and then we use binary replication logs so that all the new changes get caught up and so on. While all that is happening, your application is continuing to write to the core database. And then the failover itself, it's a matter of seconds or minutes. And then you're writing into the sharded
Yeah, so in the database terminology, we call that online. So moving into Vitess, sharding or resharding your data, all of that is supported to be online in Vitess.
What is, if anything, what is there available for tenant isolation? So say I have microservice A, microservice B, and the two should never, ever be able to look at each other's data.
Right. Yeah, what I would probably do in that scenario is I would create Keyspaces for each of those tenants. If you want to make sure that they're like distinct, because that's Keyspace is similar to a schema in MySQL terms.
Right, but there's one more thing that you need to do to get the kind of isolation that you want. the VT gates that you see here, they take parameters where you can tell a VT gate to only observe certain key spaces. So that if you send a query to that VT gate addressing a different key space, it would say that it wouldn't even be aware of the existence of that key space. So that's very good isolation.
It's a good segue for the talk that's going to follow as well, which is about how to physically store in different locations to respect compliance like GDPR. So Vitess talk in just a minute. It is a.
I'll be quiet and wait for that.
It is a problem that's definitely emerging. Regulatory compliance.
So we are trying to have our cake and eat it too. We'll see how well it goes. So you can, Vitess has its own ACL layer to prevent you from talking to tables you shouldn't. But we also kind of like secretly under the hood, we still have foreign keys that go across services. So as a DBA, you can keep different microservices honest without them necessarily knowing or caring about it. We'll see if that breaks, but so far it's been real nice.
Are your shards going to, within a shard, are you going to cross an availability zone, or is it in a shard by availability zone? How you replicate there? Is that?
Yeah, so it does have like a native concept of cells, and reads and writes default to the master, but you can elect to read from a replica as well.
So the biggest key space that we had at YouTube was 256 shards, 256 masters. And each shard had between 80 and 120 replicas distributed across 20 cells all around the world.
How many replicas?
80 to 120. So 4 to 5 replicas in 20 cells. Because YouTube traffic was very read heavy basically. And yeah, so this diagram, it doesn't show you this dimension of cells. So each of that master and each of those replicas actually is housed in a cell. So you have to have at least one cell to bring up a Vitess cluster. So I'll be talking more about the terminology and these concepts because all those concepts are needed to see how you can put together GDPR-aware cluster using this.
I have another yes. There's a common pattern of auto-incrementing keys, and way back when, that was a big problem in like geo-distributed clusters that replicated to all that jazz. Is that something you have to be aware of and plan around here? Does it just not work at all?
Yeah, so Vitess offers something called sequences. Vitess sequences that work very similar.
Okay.
But it could be a compatibility thing that you may have to change for it to work.
I'm going to show you a demo. So basically, if you use an auto-increment ID column, it doesn't make sense because you'll have duplicates across shards.
Exactly.
Yeah. So precisely to solve that, we have sequences. And so you define one particular column as a sequence. And Vitess, under the hood, keeps track of handing you out a sequence for every new row that gets inserted in that particular table across shards. So this is a unique ID across shards. And it's very efficient because they are cached. So we write once every 1,000 rows or once every 2,000 rows, but we hand them out. So they're all monotonically increasing, but not necessarily contiguous.
Yeah. I'm guessing that's not like just magically done for you when you create the table with an auto-incrementing key. You have to be aware of that.
There's a little bit of a. So all this metadata that you need to teach Vitess about how you're sharding and so on, we call that VSchema, right? And it's basically a bunch of JSON that you write to define all this. So we will, when I show you the demo, one of my tables is that, uses that, and I'll show you how this works.
Okay.
I'll let you jump on.